Good afternoon, everybody. My name is Luis Barbosa. I'm the head of business development for Webera. We, as a Webera, are partner of Amazon AWS and also other cloud vendors such as Google. We're going to talk here today briefly about AWS, especially giving an overview and the fundamentals of their service, focusing on startups. But of course, all the ideas that I'm talking here can also apply to different sizes of organizations. We're going to also present two short demos to give a practical idea of what we're talking about. Let me switch them to my home screen here. Let me know if you can see it. If you have any doubts, feel free to reach me on the chat here. I'm open to question. So I hope you can see my screen now. As I mentioned, Webera, as a AWS consulting partner, we're going to present here today introduction of AWS services, especially focusing on startups, right? Talking a little bit more about myself, I started my career back at the .com bubble, so the late 90s startups. I had my fair share of experience with them. Then I moved in my career to a more corporate environment, and then I spent about 5 years on the financial market, mainly bring credit card companies to the internet, to the web. And then I moved to the telecom industry. I spent about 10 years there, worked as system architect, then moved to a more enterprise architect, work with things like TOGAF and making sure that all the company initiatives were aligned with the strategy of the leadership team. And more recently, I would say in the last 5 or 6 years, I've been working with digital marketing. I worked mainly with a company based in LA, building their market, doing business development for them throughout Brazil and Latin America. And more recently, I got very involved and very interested on the cloud service and infrastructure, everything related to cloud, to artificial intelligence, machine learning, big data, blockchain, and so on. That's when I got a deep dive on that sense and got myself certified on both Google as a professional data engineer and AWS as a solution architect. And of course, here today we're going to talk more focused on AWS. Still talking a little bit more about Webera, our two main pillars are revenue protection and revenue creation. Within revenue protection, our idea is to provide you with managed service, information security, and hosting. So the whole idea here is that you don't need to focus on IT infrastructure or either your production environment. You can take care of all of it for you. And of course, your current environment can grow and can add new features and new functionality. On that sense, we offer DevOps service and application development. Talking about Amazon, as a consumer, what you see from Amazon is probably their home site, something like that. They started back at late 90s, selling books and CDs and other products over the web. They evolved during those years. They currently can sell probably everything, not only on their own sales as being the largest retail online site in the world. They have an operation as a marketplace. So any retailer can have their virtual store or an extension of their virtual store within Amazon, and then Amazon can help them sell and even fulfill their orders, or the merchant can fulfill the orders on their own, regardless. The amount of goods that are sold throughout Amazon website are definitely huge. So on the background, in terms of operation, in terms of logistics, what they have are something like this. This is one of their warehouses. They have a bunch of their warehouses throughout the world. And in order to control this huge operation, the amount of consumers and orders that they support, they have to have a very strong IT infrastructure. So they develop large infrastructure throughout the world. In fact, they change the model in terms of IT service. That's when they develop different models which are considered the cloud today. Not only did that to support their own operation, they now offer this as service for different customers, and then this became a second operation of them, which we currently call AWS, which Amazon Web Service. The whole idea, or the whole paradigm shift here on the cloud is the idea of elastic computing. It's something equivalent to utility service that you have. You only pay as you go. You pay whatever you consume, like electricity. So when you turn off lights, you pay during what you're using. When you turn off the switch, you stop paying for it. As a computer service, the same idea is what you call elastic computing. The amount of resource and service that you are using during the period that you need, that you want, and then once you don't need those service anymore, you simply deactivate them and you stop being billed of it. That's very helpful. Let's take these patterns of usage here. The blue line is the level of usage of a company, and the red line is the amount of capacity that the company have. Because in the past, or even today, a lot of customers have their own infrastructure. They have to invest capex budget, invest upfront for infrastructure that they're gonna use in the future. So they have to plan the amount of capacity be able to use it, right? So let's consider, for instance, an example of a credit card company or a telecom company. They have to produce or to process a bunch of invoices at the predetermined cycles of each customer with different due dates. Let's assume, for instance, a customer with a due date of the 5th, so probably during the first day of the month, the company has to process all those invoices. So they're going to have a large amount of processing requirement during that period. And once it's processed all those invoices, they probably don't need to allocate all those servers for processing. Probably a second wave or next wave going to happen in the near future. So the customer has a invoice with a due date of the 10th for instance, on the 6th or any other day, the company also going to process all those invoices and then stop processing. And notice here that the second cycle here, the second wave here, is a little shorter than the first one. So probably have less customer within that billing cycle. So what happens, all that area here in pink are moments that the company or the server of the company are idle. So it's an investment of the company that are not getting any return of it. So they have to maximize the capacity to be able to process the most heavy cycles that the company has, but during other periods, the periods that doesn't have cycles, or even cycles that are smaller than the largest one, are moments of ociousity of the servers, right? Another scenario is a company that's growing very fast. So a company that's growing like this is probably a company that's doing very well. If you look to a startup, probably they present a growing curve similar to this, or even more aggressive than this one. Regardless, the point is, once the company starts, let's assume that we have the whole year here, and each period here is a month. So if the company forecasts capacity planning that puts their initial IT infrastructure here at the red level, they started the first month with sufficient capacity, and they keep growing up to the 6th month. At this moment, which is a very good moment, the company as it's growing very fast. they now have to upscale their IT infrastructure. They have to double their IT infrastructure, moving from here to here, and then the cycle starts over. They have a very large ociousity bandwidth here that keep growing, 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 and after a few months they have to replan it and so on. So all the time they have to replan and recapacity the IT infrastructure, and every time you have a large bandwidth of ociousity. We have different scenarios here. A company that have variable peaks of processing, and they forecast the capacity on average here. So in different periods, they have a low ociousity here in red. This kind of patterns is some probably related to a company, let's say a online ticketing company, during the periods that they are selling very strongly on particular concerts, like, I don't know, U2 or Rock in Rio or whatever. Once they have those peaks, that be a major problem, because the part of the peak above their current capacity means customers that are not being served. So that's a huge problem. Probably a larger problem than the ociousity that happens during regular weekends or during regular periods of shows not so popular as Rock in Rio, for instance. For the companies that have a more predictable peaks, still on the example of online tickets, let's look at, for instance, movie tickets. They have probably a lower usage during the weekdays, and on the weekends, they have peaks of the new release of the movies. I'm not even considering here the blockbuster release like Avengers 2 or whatever. On those regular periods, they have peaks on the weekend, and the whole week there is a bunch of ociousity that they have to pay in advance for it, right? So how elastic computing or cloud solve this problem? They allocate and reallocate IT capability whenever is needed. So during the credit card company billing cycles, they allocate a bunch of servers that can process the billing cycle, and once that cycle ends, they deallocate and stop being billed for those servers, and then it happens again for a second cycle. For a company or a startup that is growing very fast, we can start the initial operation of the startup with a couple servers that are serving very well for the first month, and as long as it gets growing, is doubling in size each month, you can double also. You can follow along the capacity, the IT capacity of that growth. So start with a couple servers, and then double, go to 4, go to 8, go to 16, keep growing on the same pace of the customer demand. Even for unpredictable curves like this, you can scale up your infrastructure to support huge peaks of large sales, for instance, of a very huge ticket for a popular concert, as I mentioned the example. Or if you have a more predictable forecast, even easier, you can forecast that infrastructure grow on a predicted timeline. So Amazon offers as a pay-as-you-go service. They start with the first free tier with limited usage for one server for a limited amount of hours of usage. It's very useful for startups to experiment the initial ideas, and once they have a MVP, a minimum viable product that want to ramp up to testing and to customer validation, they can go to a regular service. The basic model of service is what they call on demand. So as much service do you use, you get billed for it, and once you stop using, you stop paying for that service. They also have the idea of reserved instance, in which you have a minimum of volume of data process that you need or that you want. So for instance, the example of the company, of the credit card company that processes invoice cycles, they on average have at least I don't know, 10 hosts, 10 machines working. So they can contract, not actually buy it, you don't have to pay in advance, but contract in advance for the 10 servers. And once you do that, you get a heavy discount on it if you're gonna use it over in a year. So you can contract the service of that period in advance. And the extra capacity that you want, you can complement it with, for instance, on-demand hosts during, for instance, the heavy billing cycle that they have. There is also another alternative to complement that processing. If you are flexible enough to waive your server during processing time, it's spot instance. The idea is spot instance is to have an open market of idle capacity from AWS. So you set the expected payment price point that you want to pay, and within that market, all the customers, all the users from Amazon set their price, and whoever pay more can use the service or can use the resources. Once somebody outbid you, of course, this person is going to take your servers, and you can stop your processing during that period and then resume in a later future. And lastly, the last model is what they call dedicated. Dedicated is when you have some security requirement or even license requirement that you have to make sure that you are locked in particular hardware. You are not sharing the hardware with some other persons. So you have a dedicated host only for you. Of course, these options cost you a little bit more. And you can even be worried about being locked in a particular vendor such as AWS, but any cloud vendor, and AWS is not different from that, they are always gonna focus on the economy of scale. So all their average price is gonna be dropped on average, and that what happened so far in the history. So their Elastic Cache service, for instance, reduced their pricing on 34%. Their storage service that they're going to talk about it really soon, S3, dropped their price on 51%. Their routing services also dropped in the last few years 20% on the pricing. So as many customer AWS have, more infrastructure they have, so they have the scalability to reduce the average price through their average customers. One particular capability which is also very interesting is the ability to deploy very rapidly, which is for startup is even more important, right? If you want to have an initial idea, want to validate that idea, you want to very quickly to deploy your idea, to have the right infrastructure within probably minutes, deploy it, test your idea, validate your hypothesis, move on from that, or pivot your idea. Considering the regular scenario of traditional companies that have the whole IT infrastructure on premises, even they put the capex upfront, as I mentioned before. Not only that, you have the time to market very hard to match, because you have to put the money, buy all the equipment that you have to have it shipped to you, which could take weeks or even months, depending on wherever you are in the world, and then have the whole timing for your technical folks to build all that infrastructure and have it available for your service. So it can take weeks or even months. When you are talking here in the cloud, to have a new instance, a new server on air, on production environment, it takes literally minutes. This idea is moving so strong that right now we're talking about the idea of serverless. So, of course, serverless, the name suggests that a server doesn't exist, but actually exists. It's provided by the cloud provider, but you as a user or consumer doesn't know about it. You simply use it as a service. if you, even database or different kind of service, you can consume it, you not having any idea what's the actual hardware or software configuration that lays below it. Between this new concept of serverless and the traditional historical idea of on-premises infrastructure, we have two other popular modules. The first one is EAS, which is infrastructure as a service. So I can deploy new machines, new hosts, new virtual machines as a service. Of course, me as a consumer, as a customer, still have the overhead of managing that infrastructure. Or I can even have platform as a service. I can have not only the layer of infrastructure, virtualized infrastructure, but also application servers. I basically get focused on deploying my application on these virtualized servers. More recently, all the cloud vendors evolved a concept called containers, which are something in between both. They have an abstraction of the virtual infrastructure that have below it, beneath it, and you can move your containers in different kind of cloud service or even a local machine. So you treat your infrastructure more or less like a platform or even a serverless, but still have an idea of the infrastructure below and being able to move that infrastructure within different clouds. So it's very interesting concept that are available right now. The whole point here is that you should be able to focus on your business, not in IT infrastructure. So, which is very usual to see in traditional companies, is that the leadership team, the decision makers, they are in a distant world trying to focus on their end users. And the IT infrastructure, IT support team are very away from that leadership and separated in different cluster of teams. So the developers doesn't talk very closely with the infrastructure folks, and they probably are separated from security. So the idea here is not the cloud provider to avoid all the IT work or infrastructure management, but to remove the redundant or repetitive or any not optimized activities that those guys perform. So those guys could work more closely between them and more aligned with company strategy. So instead of for instance, DBA to be managed table space and so on, so an infrastructure guy to be focused on storage amount and so on, they can be more focused on how the current storage or the required storage are going to support the future demands of the company. Going more in details in terms of AWS infrastructure, so they have a huge network on their own throughout the world. They have what they call regions, that are these dots here in orange, I guess. The idea of a region, it's a geographically region that has at least three availability zones. Availability zones you can interpret as a data centers or one or more data centers. And within a region, as I mentioned, have at least three availability zones. You could consider three different data centers, which are close enough to be considered a region, but spread enough so they can be considering a backup from each other. So for example, East Coast of US in DC area, they can have in the north part of the metro area a data center, another one in the south part of the metro area, and another part of west part, whatever. In case of have a hurricane or whatever flooding in the data center on the east, probably the two others in the north and the south part of the region are gonna cover for that one. So every time you got covered with different backup sites. You have that kind of idea throughout the world. You have the east part of US, mid area of US, West Coast, South America, different regions in Europe, East Asia and Japan, South Asia and Oceania. They also have this idea of edge points, the one in blue. So for instance, they don't have a region in Florida, but they have an edge area here. So if you're a customer in Florida or in Miami, if you want to use AWS infrastructure, you don't have to connect through public internet network to a data center in DC, for instance. You connect through a edge point still here in Florida, and then we are interconnected from there to DC or any other part that you want to go. Because all those points here, or almost 99% of those points here, are connected through proprietary infrastructure, network infrastructure from AWS. They don't use outsource infrastructure to do so. They may use it in very particular case, but in general, they have their own infrastructure connecting all those regions and edge locations. They have different kind of service. I'm gonna cover some of them. I'm showing you guys a map of their main service. It's a quite old map here. It's probably their home screen from back at 2013. If you see the current home screen, they have much more service than that. They have over 200-300 servers and growing every single day. So trying to simplify our discussion here, I chose a smaller set of servers. So they have different kinds of service related to computing power, storage power, networking, database, security, and management. So you're gonna see example on each one of those areas. Starting with compute, the main service is EC2, it's Elastic Compute Cloud, in which you are able to deploy hosting servers either on Unix or Linux operating system. You don't have even to worry in terms of licensing of the operating system. The cost of it is embedded within the pricing of the service, so don't have to purchase, for instance, a Windows Server license. You simply deploy for a Windows Server, and you are going to be billed on hourly base of usage of it, including everything, hardware, operational system, and so on. Another resource in terms of computing powers is ELB, Elastic Loading Balancing, in which you can have a front-end piece of it, so all the customers, all the end users from your service that come in can be distributed in different EC2 or other hosting instance on your environment. Associated also with the load balancer, you have the feature of auto scale. So you can start the operation with a single host in front of a load balancer and set up. So once you have a larger demands, a larger number of end users using your service, you can grow your instance and your host dynamically. You can start with one, then double, then triple, or whatever amount serve you best. And also, once you reduce your demand, you can also undeploy the servers that you're not using anymore, and of course, stop being billed of it. In terms of storage, the most basic service, it's EBS, is Elastic Block Storage, so the kind of storage that you attach, that you deploy to operation system. It can vary from gigabyte to terabytes that you can use to storage your archives, your files within the operational system. And then you have the service of S3, which is called simple server storage, that are used to store objects, not storage in the level of blocks that are attached to the operation system, but something similar to what you have to your cloud drive. If you use, for instance, Dropbox, in which you can save object documents and so on. S3 is very similar to that. You can have the zettabytes of storage with a very strong durability, 11 nines of durability. So the probability of you losing a file object within that storage is insignificant. And all those objects are stored in different availability zones, so they are recovered from each other. They also can be encrypted if you want. They even have a web server on top of it. So if you want to expose your objects, your files through the web, you can use the web service that are embedded within S3. In fact, we're gonna show you that example during our first demo. Then we have Glacier, which is a variation of S3, two files that used or stored as old archives. The difference here is that it's very cheap. It's less than a cent of a dollar per gigabyte per month. The downside here is that it's gonna take a couple hours to recover your original file. So it's very useful to archive or to store documents for audition process or any compliance process that have to store it for 5, 10, or even more years, and have to recover in the case of a compliance process. So let's see our demo. So we're gonna actually take a set of HTMLs and pictures, which of course compose a website, a static website. Also with the style sheet file that organize all the layout of the website. Publish those files store those files on a S3 environment, and publish them throughout the web, so they can serve as my static website for my company with a very simple solution. Not only for sites or HTMLs or pictures, can be used to store any file. Even this presentation here, let's do this. This presentation here, I can save it as a PDF and publish on S3. So let me access here the console. Let's switch to English. And then here you can see the whole different set of services that AWS offers. So in terms of storage, we're going to use S3. In S3, The first thing that you have to do is to create a bucket. A bucket's like a folder, is an area that you're gonna store your files. The bucket naming system, it's worldwide, it's global. So the name that you choose here is unique for everybody in the world. So let me create here AWS demo dot webera.com. And as I mentioned, you can choose different regions. I can choose a region in Europe, in Canada, and in Asia, in US. Let's choose Virginia. And then you can set also different configuration like versioning, logs, tags, encryption. Let's keep all the defaults. Monitoring, one of the services in terms of monitoring is called CloudWatch. CloudWatch. Um, let's keep all the defaults. And then by default, have at least privilege access. So by default, all the public access can be blocked. So I'm gonna uncheck that. So people are gonna be able to public, so through internet, through a web server, access that file or the files within that bucket. And confirming all configuration, we are good to go. He's creating our bucket. Within our bucket, we can create folders or simply deploy or upload our files. Let's upload the presentation here. Uploading the PDF of our presentation. You're setting basic permissions and using all the defaults. Then I can choose the kind of storage that I use. Can use standard or single availability zone or Glacier that I mentioned. They now have Deep Archive, which is a more archiving property of Glacier, which take longer to recover the original file, but of course you can pay even cheaper. Confirming our configurations and then upload. So it's uploading our file. All right. Once we have here, there is a last step that I have to do here is to make it public. So I then can give permission to people from the public internet to have access on that file. Let me take out the space here so this cannot get confusing, and then make it public. So he's warning me that everyone in the internet can have access to this file. Okay, no problem. I'm sure of it. So now it's public. So it can be accessed through this URL that are being presented here, which is amazonws.com prefixed with the service F3, could be the name of the region here if I chose a different region. Then the name of the bucket. The name of the bucket that I chose was AWS demo.webera.com, and then the name of the file, intro.aws startups.pdf. So from wherever you are, you can access now this file here, right? Our presentation. I have here a whole website. I guess it's from a pub, if I'm not mistaken. Let me download. The website is basically a set of HTML files, uh, a set of image, JPEGs or PNG images, and lastly, a style sheet that can do the layout of those HTMLs and images, right? So I have basically to upload those files and make them public. Then those files would work as a, 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 So let's do this. Back at our our site here, let's create a folder of HTML. I'm not going to use any cryptography. Within that folder, I'm going to upload all my HTML files. I have them here. Okay, all of them are here. I can even here make them public already. So I'm going to grant public access. They are, again, it warning me of the risk. I'm going to still use the standard access, confirm your configuration, then upload. I'm going to create another folder to the style sheets. And then upload the style sheets. I guess I have only one style sheet here. Style.css. Next. Grant public access. Standard storage, and then upload. Go back on directory and create the folder for images. Within the folder of image, I'm gonna upload the images. Next, grant public access. I'm okay with the warning. And here we go. So our initial entry point is the index HTML, which are based in that URL. Whatever you are, you can access our website. So again, you have a domain amazon.aws.com with a prefix of S3 or whatever region you're using, then the bucket slash the bucket name slash the folder and slash the file that I'm accessing. So I have a simple website that I got from all the customer of ours. Or I guess it's an example actually. But again, so a very simple static website that can be published over the web within minutes, right? That's the point of the demo here. Moving on in other service, then we can talk about the networking service. So they have the service of VPC, Virtual Private Cloud. So everything that you have with a regular network, you have it as a virtual concept here. If you have a physical network, you can map that same ideas within a virtual private cloud, a VPC, on which you can group or put together different hosts within your environment and especially configure the security levels in between different VPCs. From your company to the cloud, you normally connect to a secure network. You can of course use public internet, but within or over the public internet, you put a layer of security through a VPN tunnel. So from your physical company, physical location, you can access your cloud services very securely. And if you have the idea of a hybrid cloud in which part of the service are in the cloud and parts are still on premises, and you have in both environment have to connect or communicate both ways, you can have a dedicated link which called direct connect, so the on-premise servers can communicate with cloud servers and the other way around. Another important service within network is Route 53, which is a full-blown DNS service. So the DNS server will translate name domains to IP addresses, right? So whatever IP address the web service, for instance, for Webera has right now, we don't access as a user, don't access using the IP address. We use a name, right? So I access www.webera.com. I don't use reference for the IP address. Talking about database, we have two kinds of database currently as a technology. The more traditional and more heavy usually ones are the relational ones that are based on SQL language. The main examples you can see in the markets are Oracle database, Access, SQL servers, MySQL in terms of open source, IBM DB2, Postgres, and so on. There is a different paradigm in terms of database, which is NoSQL, the database that are not based in relationship and tables and SQL language. As an example of those, we have MongoDB, Cassandra, Redis, HBase, and so on. Within the AWS environment, we can have relational database, RDS, in two different models. One, it's completely managed by the customer. The customer simply allocate a operational system instance, a EC2 instance, and then by themselves, they deploy the database on top of it and manage on their own. The second model is RDS database provided by AWS as a infrastructure as a service. So you, as a user, as an infrastructure manager, simply required from AWS, I wanna Oracle database or SQL Server database or MySQL database, and it's automatically deployed to you. The amount of effort that you have to manage those services are minimal. And then they have a more comprehensive model or serverless model in which is 100% managed by AWS in terms of capacity. So as much as hardware infrastructure need to support or to address your demand, they are automatically provided by AWS. But not only that, the management services are completely transparent for you. You use a whole database as a server, as a service. The example of it is DynamoDB. That's actually the example that we're going to use on our last demo. So in terms of relational database that I provide as an infrastructure service from AWS, are the main vendors on the market, the open source MySQL, Oracle SQL, and SQL Server, right? And as a service or serverless database, the main one, NoSQL one, is DynamoDB. DynamoDB works in the paradigm of a key value pair. You can storage any data on that idea and don't have to worry about relationship or SQL or being as a serverless model. You don't have any overheads in terms of management of it. You don't have to worry about indexing, creating table space, and so on. So those are the main examples. In terms of database, we're going to see a demo on DynamoDB, as I mentioned. Moving on app service, one of the most interesting app service that they have is CloudFront. It's a web cache server that can be placed in front of your web server. It actually works in conjunction with the edge location. So even the very small example that we did on the first demo of hosting a small web server throughout S3, if you can put a CloudFront in front of it, considering that our website right now is hosted on the east part of US, if someone from Japan want to access, right now they would have to navigate or to travel through public internet from Japan to East US. But if you had activated the CloudFront service, the CloudFront will do a cache within the closest edge location, for instance, from Japan. So instead of navigating, traversing the whole internet from Japan to East West to access that content, he would access a copy of it very close to them with a very low latency. Another interesting service is simple notification service, SNS. You can send emails or short message to notify a customer or administrative person for any particular situation of your application. Another service is called SQS, a simple queue service, is a service usually used to decouple the back-end part from the front-end part of your service or of your application. So if your application process a large amount of requests asynchronously, for instance, buying tickets or uh, getting codes for financial market, whatever it is, if you have a large amount and don't have to process that online in real time to your customer, you have the ability to process them asynchronously, and as soon as the request is processed, you can give back a response to your end user. SQS, it's a very, very useful service. Cloud search, if you have a different kind of documents of elements storage, or if you want to search within those documents, cloud search is a service 100% available to you. And last, talking about deployment and administration, the main application environments or language can be packed and deployed within production environment with very little overhead, seamlessly to your administration through Beanstalk. Another service for the administration is CloudFormation. So as everything in the cloud are virtual resources that you don't actually have physical access to it, you can redeploy different copies of your infrastructure to simply through a configuration file. That's what CloudFormation manages. So if you have a production environment, you want to replicate through QA environment or development environment, you simply get the configuration file from production and redeploy the infrastructure through CloudFormation based on that template configuration. It's very, very useful. In terms of security is something that every single talk or webinar, wherever uh, discussion that you have about the cloud, it's something that you come up with. All the providers are very concerned about the topic. AWS is no different. The idea here is to have a separate or divided responsibility of it. So the cloud vendor or AWS would be responsible to uh, physical access to the data centers, hardware security, and even operational system of the host are secured by AWS. But of course, part of the security responsibility of the customer as it manage access to each resource that they deploy. So usage of operation system or application or customer data that they store in the database or even files or objects, if the customer are able to choose if they want to encrypt that files, if they want to grant permission for particular users. So if they do these kind of things wrongly, unauthorized people can access those files, but in that case, it won't be AWS responsibility. It'd be on the customer side, right? So it's a joint effort here to reach high level of security. So finally, showing our last demo. Let me access them. The DynamoDB service. Let's get back at home of AWS. And then in terms of database, we're gonna use DynamoDB. In DynamoDB, I don't need to be a DBA or something like that to use it. I'm gonna simply create a table here. Let's call this table USD to euro. So we're gonna store on that table all the codes from US dollars to euro. as I mentioned, DynamoDB store objects as key value pairs. Our key value pair here is going to be the code, and the other information that we're going to have is the date, right? And the code is going to be numerical and the date is a string, right? So I'm going to create our table. The table is being created. I'm going to use a spreadsheet here to help us on that operation. Let's create a spreadsheet here, a spreadsheet called, oh, yeah, so it's created. Of course, at this point, the table is empty. There is no value here, and I can create a code. Let's see what's the code currently for USD to euro. So it's 0.91, and today it's October 9th. Let's hash that information here. So the code today is 91 cents, and the date today is October 9th of 19. Save. So now I have that record for today. And of course, I don't want to put every single day manually here. Let's do a batch load. And even to query the historical codes, let me use a very interesting resource that I have on the spreadsheet here. So we got here from, so we're getting here from September 1st up to September 25th. Perfect. And then we're gonna only take the date from the timestamp that you have here. If the format day, month, year, or month, day, year, right, right. Call this date, and then copy it to a different tab here. So this one, it's okay. Let us save my CVS. Unfortunately, DynamoDB doesn't support CVS batch import. You're going to have to convert that file to a CVS using a template. So let's use this website here. So just to show you the file that we're generating of CVS, it's all the codes, almost the whole September month with codes, all the information separated by commas, as you can see here. I'm going to select the file that we generated, then use a template. I have a cheat sheet here. Let me get the template here. Gonna convert. So JSON, which is the format supported by DynamoDB, is those ones with brackets. And then we're gonna save a JSON file. So let's download the file. And then one simple way to access a host on the cloud is using terminal. If you're using a Mac machine or Windows machine, you probably have access to a terminal application. Let's access. Let me close this one and open a brand new one. So we're going to use the directory downloads, in which I saved the JSON file. So all the JSON files that I have are those. And then I'm going to put a command AWS to connect to AWS service, in particular on DynamoDB service. I wanted to batch write an item with the parameter of request item items of my file of USD euro.json. I missed something on the command here. AWS 9. I wrote it wrong. DB batch write. That's it. Perfect. It looked at process everything okay. Let's go back to our console and refresh our database. So we have all the codes, the historical codes for September right here. For instance, on September 23rd, the code was 90 cents and so on, right? That's our last demo. Once again, feel free to reach us. We have our contact information here. Don't forget also that that even this presentation are available on the S3 service that we put on. See you all next time. Have a great weekend. Bye bye, guys.